We're here today on McMurdo Sound to conduct a research project to study the possibility that Weddell seals use a magnetic sense to navigate. We're doing this by attaching instruments to the seals. It records their behavior, and we then use carefully designed experiments to determine whether the behavior matches predictions that we have for a seal or any organism that would be using a magnetic sense.
Imagine your life where you spend 95% of your time holding your breath and yet performing all the normal functions that you do in your daily life, feeding, sleeping, other types of activities, but you're doing it while you're holding your breath. And you can only breathe at certain locations. Seals do precisely this, but if they don't have a chance to breathe, they're just like humans or other mammals. They will drown. So being able to reliably travel between sparsely located breathing holes is absolutely critical for their ability to live under this ice. And we think that has resulted in the evolution of a very precise geomagnetic navigational ability. At least that's our hypothesis.
The Weddell seal is so fascinating is because they're doing things we could never do. They're holding their breath for an hour. They're exercising while they're doing it. They're going to depths that would just crush our lungs. And they can swim just routinely at about 2 meters per second. Michael Phelps got a gold medal for going 1.9 meters per second. So it gives you an idea of just what kind of an athlete these guys are.
The problem with Weddell seals and all marine mammals is that once they dive beneath the surface, and especially under ice, we cannot observe them. They're very hard to track. So what we've developed over the years is an instrument that we attach to the animal that allows us to travel vicariously with them, look over their head, and see basically their worldview under the ice. And we do that with this video data recorder, which we've developed with funding from the National Science Foundation. It has an array of sensors and a small video camera with near-infrared LEDs. It will record 27 hours of video programmable, that is, we can spread it over an extended period of time, and sensors that allow us to recreate its three-dimensional dive path through the water column.
Well, based on what is known about other animals that we believe are using a magnetic sense, there should be changes in behavior when an animal is in a different magnetic field. And so we designed an experiment, a rather rigorous experiment, that involves placing the same animal in 3 different magnetic fields. And we expect its behavior to be different in those 3 magnetic fields. And so, as I said, our instrumentation allows us to look at behavior very carefully in 3 dimensions. And so we have a really good opportunity to see changes in behavior.
We'll be coming back in subsequent seasons. We hope to be able to do 3 to 4 seals at least per season, depending on weather, and come out of this project with a sample size of seals that may be anywhere from 12 to 14, each with 3 deployments. That will give us the amount of data that we need to statistically analyze and look for these hypothesized behaviors.